They start to shine like sunglasses blocking glare.
Hello. So we are going to talk about diffraction grating. You need to understand first these concepts. That if you have only one slit and you have a light source that gives some light, basically there's some diffraction happens at the edges in this slit, that the light bends inside the slits, kind of scattered and start to bend inside, and basically create some points of like bright light, which is constructive interference, and parts of destructive interference. So this light, when it goes here inside this slit, is going to start to bend. Okay. Then if we have a viewing screen here, what we will see that an area of high constructive interference, then a valley of destructive interference, then high constructive interference, then low, and so on. So what happens if we have actually two slits, not just one slit, like this one? So when we have two slits, have a basic small difference. So we have two slits here that the light goes inside and bend. We are going to have here some positions of constructive interference and some positions of destructive interference, and by the end we are going to have a light, very bright spots, then a dark spot, then a bright spot, dark spot, and so on. Dark, this is dark. So basic bright spot, dark spot, bright spot, dark spot, bright, dark, and so on. And this is basically for one wavelength, just for one light with one specific wavelength. We have this. So basically, for each wavelength, which means for each color, we are going to have different kind of the location of the bright spots for this wavelength is going to be different for different colors. And that's how we use the diffraction grating lens or tool itself. It's basic diffraction grating. It's kind of a device like a screen, but it has many slits. Okay, many openings. Basically, slits means openings. It's like maybe thousands per centimeter. Okay, thousands of centimeters. So for example, we'd say we have 1,000 slits per maybe even millimeter. Okay, and what happens here, that when we have a light source, that the light propagate inside this diffraction grating, what's going to happen is that the light here is going to create some constructive and destructive interference for different wavelengths. So by the end, this is basically as if there's a lot of interference between the light comes out of each slit, until by the end you are going to have basically the all the lights, basically one by one on each side, separated, because as we know, each light, each color has different wavelength. and so on. Then we have this one, L1. Then we are going to have all the colors here as the first order. Then all the colors up for the second order. And we would like to measure basically these distances, the distance or the height for each wavelength, so that we can determine the wavelength of each one based on the diffraction grating. Okay, so we are going to do this inside the experiment to see how could we evaluate the diffraction or the value of the wavelength itself. So this is the setup. So we have here the diffracting scale with a slit in the middle, the scale holder. We have here the diffraction grating with 600 lines per millimeter. We have here a slit mask. We have here a diffraction plate with different shapes or slits, kind of 8 shapes. We have the plate holder, the light source, and we have the PASCO optics bench, and of course the lab manual. So let's make the setup. First, we'd like to connect this light source to the power supply, to the outlet. So we have it here is lighting. Place it on the optics bench. Then we are going to place the diffraction scale holder and basically put this one on top of it. Then we are going to place the holder here. We'll place here the slit mask, and we place the diffraction plate on the other side. So this is going to be the setup. So let's go and turn off the light so that we can see. First, we need to make sure that the light here coming from the light source is actually going inside the slit mask, not here. So you need to start to move the scale right and left until we have the light actually going through the slit mask. Okay? Then after that, we are going to hold the end of the optics bench, getting up here, for example. Then what we need here is to observe. So now we are going to hold the end of the bench and approach it here. And I need you to look at the multi-slits, maybe 2. I'm going to select the G1 that has many slits. Then I will look directly towards the light. Then I start to go right and left, basically push this one left and right, and see the constructive interference and the destructive interference. When we move it like here, we should be able to observe it by our eyes. So we basically, this is the interference of light when it goes through slits. So I would prefer in general to make this one approaching, so it becomes almost in front of the scale, and we look here and I start to go left and right to see some constructive interference and destructive interference. Okay, so we can see that we still see the light, except we are not in front of the slits or the opening itself. After doing this experiment, we are going to bring this holder back. We will remove the slit mask, the diffraction plate, and we will put the diffraction grating, this one here. We need to make sure that the slit of the scale ruler here, it's exactly in the middle. Okay. Then after doing this, let's look at here. So you see the light, this is directly in front of it. And let's look for the first color spectrum, light spectrum. Let's go right. See? Now we can see. Let's zoom in so that we can see better. So here the light directly facing the slit. Then we go right and look for the first order light. So we can see here there's purple, comes green, yellow, red. Let's go look again, red. So this is the highest. Okay, so we need to determine the wavelengths. So we can see at the top of each color there's a number, basically from the ruler itself. So we can see it here, for example. You can see that the purple one, it's approximately 9.5. The green is 10. Then basically we can find the other numbers. If we went over more and more, we can see the second order light. You can see this one. This is almost the second order. You see? Second order. If we went the opposite, we should basically find the first spectrum, followed that by the second spectrum. Okay? And as we said, if you are here, basically you can see that it's obvious that the purple one, it's on the top of 9 centimeter, which is basically the place of my finger here. So we take these measurements so that we can calculate the wavelengths. So this is the diffraction grating basically, and how to find the wavelength of different lights with different colors. I hope you liked the lab for today and you've learned something beneficial. If you liked it, please press the like button and subscribe, and wait for me for our next physics lab. Thank you.
Right, one plane remains, a dance of light.